Hi everybody, this will be your video on the scientific method this week. I do not expect you to write down everything word for word. I will tell you what I need you to write down. And remember, you can always pause me. I'm going to try to make these videos as short as I can so that it's not, killing your internet availability. But remember, you can always pause, so please take advantage of that. Okay, so the scientific method, stop me right here. What are the steps you recall? Why is the scientific method important? Think about it. Here are the steps. Please write these down. I hope you can see my cursor here. Ask a question. Here's our start point. Do background research. Build or construct your hypothesis. This piece in here is important. Sometimes people make one observation and they make a hunch or a hypothesis based off of one observation or one story. That's not good science, okay? So you need to research the actual subject, okay, before you actually build that hypothesis. Then we test with an experiment, analyze results, and draw our conclusion. Then we have to actually kind of hop back up here to our hypothesis. Was the hypothesis true based on what our data is telling us, or was it false or partially true? And then we need to report that. So if you get here and your hypothesis is not supported, then notice we have this loop here. So try again. What happened? Were there differences in the groups that were overlooked? Were the methods very good? Maybe it was a design flaw. Maybe you didn't do the experiment right, or the researchers didn't. Do you need more data or subjects? If this, it's possible that you tested one person or one condition and then it proved you false. Is that good science? No. Okay, you generally need to test things more than once and have many groups. So it might be a case of increasing the size of your experiment. Or it could be something new or previously unconsidered. So there are a lot of factors that you might need to think about as you come back to this loop. And that's a huge point about the scientific method, is that it's never done. You're never done asking questions, okay? But this communication piece is super important, all right? Why is that? If you discover the cure for something, if you don't tell people about it and have other scientists check it out, then it doesn't matter what you've done. So you need to communicate, but you also need to communicate clearly. Be very specific in what you say. So yes, you should write down this slide. You can pause me to do that. The next slide, do not. It's too much writing. I'm going to get to the next slide and I want you to read it. Okay? I will briefly talk through it, but pause me at some point. So here is an example. You're not writing this slide down. Okay? Any worthy scientific experiment starts with an observation. And here's an example of that. I observed that being on my phone makes me antsy. Next, ask your question. Include a why or a how. How does time spent on devices affect my mood? Come up with after researching, hypothesis time. If I reduce time on my devices, then I will feel more calm. So if, then, that cause and effect, we're going to try to predict what we think might happen. Next, design your experiment. This needs to be step by step. Okay, you need to take data. Next, display your data in tables and charts. That'll be on the next slide. There are no opinions here. This is what was recorded. This is what researchers wrote down. There's really no words here other than labels. Okay, and you'll see what I mean on the next slide. Lastly, write your conclusion. We have a step-by-step method we will engage in later on. Okay. Simple data tables. Here's my controlled trial. Okay. I have Monday through Friday. We didn't limit our time on devices. We just recorded how much time we spent on those devices and then how antsy we felt 1 to 5. 5 being the worst, 1 being not so antsy at all. Now, our experiment is where we controlled the amount of time. So it was about 4. I cut it down to a quarter, so only 1 hour a day. Notice what happens to the level of antsiness as the week goes on. Again, these are just data tables. Okay. Now here's a sample conclusion, and there are parts that are very important. The biggest pieces that you see here, restate your hypothesis. Just say it again. Okay. The next portion of your conclusion should be to explain your data. This is where you try to interpret what those numbers are telling you. So in the beginning, the average time was spent on devices was 4.1 hours a day. The average ANSI feeling during that trial was 3.5. Okay, so above where we want it to be. So we cut the amount of time down to about an hour a day, and then we did a second trial of 1 hour per day, and that ANSI feeling reduced. So we got it to reduce from 3.5 to 1.9. That's good. Okay, it decreased. That's what we changing something produced a different result. Okay, and then here's where some interpretation comes in. The results demonstrate that cutting down on social media or device time leads to feeling less antsy. The data suggests that at first, limiting time on devices creates some antsiness, but that feeling goes away. A limitation of this experiment, so this isn't rock hard science yet, is it? Because I only studied one test subject, me. Okay? Now, from this data, the hypothesis is supported. Notice I didn't say the hypothesis is true and I proved it. No, the data from this experiment supports the hypothesis. Okay, if every single 8th grader at KMS also did this, I bet you the hypothesis would not be supported by some of you, some of your data. Many others might. I don't know. We'd have to run that and find out. But these are the basic parts. Restate hypothesis, interpret your data, and then you support or reject your hypothesis. Okay? All right, so as you view this, I did run very quickly through this. Keep this in mind as you see these steps. Why are we doing this? What is the point of having this procedure? And you will see, you'll see different versions of this scientific method. You know, they might start it off earlier with building your hypothesis. But the basic idea is you're asking a question, you have something you're trying to figure out, you do your research on it, and you try to design a way to answer your question, okay? And so why do we do this? It's to organize our experiment, organize our thoughts, and try to remove any outside factors that might be affecting the scientific process. And so we'll talk about that more at a later date, but make sure you have this copied down at least once into your notebook. If you have questions, comments, thoughts, or concerns, please let me know. Okay, I think that's it. You're done with this video.